All right, welcome. Today we're going to start talking about the power rule and some basic rules for derivatives. All right, so I guess the baby version of the theorem is this, that if you take a derivative of a constant, you always get 0. Okay? You can think of it in lots of ways. You can just use the definition, but a constant has a flat graph, so its tangent line is flat, and flat has slope 0, so that's why the derivative is 0. But more useful, this is called the power rule. Not more useful. It applies to more things. It says for r a real number, the derivative of x to the r is r x to the r minus 1. Okay? So this is a fun rule. It only works when r is a constant here. Okay? So example, the derivative of x to the 42 power. The 42 comes down, and then it's 42 minus 1, so that's 41. Another example, we can do the derivative of x to the 1/2. So the 1/2 comes down, and then we subtract 1 from the top. So it's 1/2 x to the minus 1/2. All right, that's the power rule. It's pretty easy, pretty handy. All right, here is a list of general derivative rules, the easy ones. So let's do the following one. First says the derivative of a constant times a function. The constant pulls outside, and you just get k times f prime. It's very important to remember, only constants pull out. Okay? And 2, the derivative of a sum is the sum of the derivatives. Okay, so it distributes across sums. Note, this is very important, f times g is not f prime g prime. It's a sad fact, just is not true. So it does not distribute against products, but it does work for sums, not products. We'll come to products later. Anyway, with these rules, you get to do a bunch of examples that are more complicated things put together, and you just take the derivative of each piece individually. So for example, if you want to do the derivative of 3x to the 50 plus 8x to the minus 1/2, well, what you can do is, first of all, take the derivative of each piece. Now normally people will just do this all in their heads, but let's write it out in gory detail here. So it splits up the sum, and next the constants pull out. And then finally, you take the derivative there using the power rule. So it's 3 times 50 x to the 49 plus 8 times minus 1/2 times x, and you take minus 1/2, subtract 1, so you get minus 3/2. And there's the answer. All right, let's try another example. Let's do the derivative of 2x to the 100th plus 10x to the minus 1/5. Okay? All right, so the constants pull out, 2, and then you have to take the derivative of x to the 100th, so that's 100 x to the 99. We subtracted 1 from it. And then the 10 pulls out, because it's a constant, and you take the derivative of x to the minus 1/5, so the minus 1/5 pulls out, and then you have to subtract 1 from that, so you get minus 6/5. And there you go. That's the derivative. Ciao.